Hello, this is how we can solve combustion analysis. So I'm going to solve two questions here. I will explain how to find the empirical formula and the molecular formula. So first question is the chemical compound containing carbon, hydrogen, oxygen that contains occur naturally in fruits. So we have a compound that contains CHO, but we don't know the formula. For the molar mass of that compound is given as 116 grams per mole. So after it completely combusted, combustion means this carbon, hydrogen, oxygen containing compound completely burn to produce carbon dioxide and water. So carbon dioxide produced 22.12 grams and water 9.06 grams. Now these are the details given. Using the data given, we need to find out first what is the empirical formula and then molecular formula using the molar mass. Now let's see step by step how we can find empirical formula and the molecular formula. First let's calculate the number of moles of carbon dioxide. So after completely combusted, 22.12 grams of carbon dioxide CO2 produced. So how many moles of CO2? 22.12 grams we need to divide by carbon dioxide molar mass. Carbon dioxide molar mass is 44 grams per mole. So after this division, we can get the answer 0.503 moles of CO2. Now, if you take 1 mole of CO2, it contains 1 carbon atom, 1 mole of carbon. If you take 0.503 moles of carbon dioxide, that contains the same number of carbons. So number of carbon moles is equal 0.503 moles because 1 mole of CO2 contains 1 mole of carbon, 2 moles of oxygen, right? So 0.503 moles contain same amount of carbon. Now let's move on to water. So water produced 9.06 grams. So how we can convert grams into moles? Divide by water molar mass 18 grams per mole. It is equal to 0.503 moles. But if you take 1 mole of H2O, that contains 2 moles of hydrogen. So you take 1, it contains 2. So if you take 0.503, that contains double that amount of hydrogen moles, that is 0.503 multiplied by 2, 1.007 moles of hydrogen inside water. Now we found how many carbons and how many hydrogens inside that compound. Okay, so let's find out grams. We have moles. Let's convert that carbon moles and hydrogen moles into grams. So grams of carbon, number of moles of carbon multiplied by carbon molar mass. It is 6.036 grams. Grams of hydrogen is equal moles of hydrogen multiplied by hydrogen. Here we need to consider only one hydrogen atom mass, that is 1.007 grams. Now this is carbon mass and this is hydrogen mass, and we know total mass. Then we can calculate easily what is the mass contributed by oxygen, right? So amount of oxygen, the mass of oxygen is the total mass 9.73 grams minus the mass of carbon plus mass of hydrogen, and the answer is 2.69 grams of oxygen in that compound. Now let's calculate moles of oxygen. 2.69 grams divided by 16. One oxygen atom mass is 16 grams per mole. So the moles of oxygen is 0.168. Okay, now we found everything required to calculate empirical formula. We know number of moles of carbon, hydrogen and oxygen. Now let's go to a table I added here as a table. So number of moles of carbon, hydrogen, oxygen. So if we have numbers like this, let's divide these numbers by the smallest number. Then we can get the whole number ratio. To get the whole number ratio, let's divide each number by the smallest number. Here is 0.168. So I divide all three by 0.168. Then we can get the ratio as 361. So empirical formula should be then C3, 3 carbon atoms, H6, 6 carbon hydrogen atoms and 1 oxygen. C3H6O is our empirical formula. Now empirical formula is not the actual one. Let's find out what is the actual formula or the molecular formula. The molecular formula mass is given as 116 grams per mole. It is in the question. Now if we multiply n times, 1 times or 2 times or 3 times, n times, this empirical formula mass is equal 116. So we need to find out what is the n number. So I added here n times 1 carbon is 12 grams times 3 plus 1 hydrogen is 1 grams times there are 6 hydrogens plus 1 oxygen 16 times 1. So if we add all these together times n is equal 116. So use the calculator to find out the mass of 658. So n times 58 is 116. So n is equal to, right? So n is equal to means the actual formula or the molecular formula should be 2 times empirical formula, right? So its molecular formula is 2 times our empirical formula C3H6, that is C6H12O2 is our molecular formula. Okay, I hope you will understand now how to find the empirical formula and the molecular formula. Let's move on to our second question, the same format. Okay, the second question is, I will open the entire page here. The sample of urea contains 1.21 grams of nitrogen, 0.161 grams of hydrogen, 0.480 grams of carbon and 0.640 grams of oxygen. So each of these atoms' weights are given for you. Now you need to find out the empirical formula of urea, right? What is the first step? First find out, if you have a gram quantity, find out the number of moles. So how you can find out a number of moles? Divide each masses by their molar masses. So nitrogen is 14. So let's divide 1.121 grams, 14 grams per mole. Hydrogen mass is 1 grams per mole. You can get these molar, the atomic masses from the periodic table, right? So carbon 12 grams per mole, oxygen 16 grams per mole. So each gram quantity divided by their masses, and then we can get the moles. This much moles: 0.080 nitrogen, 0.161 hydrogen moles, 0.04 carbons and 0.04 moles of oxygen. Now to get the whole number ratio, let's divide these number of moles by the smallest possible number. So among these four, smallest possible is 0.604. So I divide all 4 by the smallest number to get the whole number ratio. Then we can get the whole number ratio 2411. Then our empirical formula is N2H4 carbon 1 and oxygen 1, N2H4CO. Right? This is our empirical formula. What is the molecular formula? The same like in the first question, the molecular weight is given as 60.06 grams per mole. And then what is the molecular formula? So n times our empirical formula mass is equal 60.06. So empirical formula mass, this is how we calculate, is equal 60.06, n is equal 1. So if n is equal 1, molecular formula is same like as empirical formula. It is N2H4CO is the urea actual molecular formula. I hope you all understand now how to calculate empirical formula and the molecular formula. Thanks for watching.